Okay, students, welcome to the class of calculus. Today we will study that how to find out the area between two curves, as we have already discussed or started exercise 5.6, where we have solved multiple questions how to find out the area between the two curves. So today I will discuss some more questions, but with the help of a mathematical software named as Mathematica. So today my question is find the area of the region enclosed by the curves in exercise 81 to 84. So we will try to cover some of the questions from question number 81. So these are two curves. So we want to find out the area between these two curves. So here I have written the solution. So first I express y in terms of x. From the second curve, I also express y in terms of x. For the limits, I want to equate these two curves. So put 4 minus 4x square equal to x raised to power 4 minus 1. After that, I get a quadratic equation and solve it. So I will get the two roots as a real roots and two roots as a imaginary roots. So we need to ignore the imaginary roots. So x equal to -1 and +1 means that our limits are from -1 to +1. We know that the area between two curves is we need to integrate the difference of these two curves, either write down y1 minus y2 or y2 minus y1, but with the absolute sense. Absolute sense means if your answer is negative, so it automatically change the sign in as a positive, because the area under the curve or area between two curves cannot be negative and 0. So my y1 minus y2 was x4 plus 4x square minus 5. So as I integrate it, so everybody know how to integrate it. So I will get this expression, and after applying the limits, I will get 104 over 15 square units. So that is the area enclosed between these two curves. So let's find out the area between two curves by the help of Mathematica. So as you know that these are my two curves, so I write down function f of x as 4 minus 4x square, and g of x is x raised to power 4 minus 1. I execute these two curves. After that, I give the command of plot, and where I mention the limits are from -2 to +2. So just wait as the first curve is being executing. So as it be executed, I will run the second command. So students, I am going to execute this command. So here I get the plot of first function where the area between x-axis and the curve is mentioned. So now I am going to plot the second curve. So that is the second curve. Second curve is actually x raised to power 4 minus 1. But actually I need to find out the area between these two curves. So I write down the command plot f of x comma g of x. So here is the area, but we want to only find out the area, or we want to shade only that area that is enclosed or bounded by these two curves. So but here some exterior region is also excluded. So but we want to find out the area from -1 to +1. For that, you need to give some extra commands. So what are these commands? So I am going to again execute the command. Okay, I give the command of plot f of x comma g of x and plot style thick and ignore the filling axis. So that is the graph of f of x and g of x. And here I am giving some extra condition here that fill the region between the curve 1 represent curve 1 and 2 represent curve 2. So that is the region. After that, I need to merge these two blocks. So use show command f of x comma g of x. Okay, there is some error. I have actually used the wrong names here. So the first plot that I want to merge is plot 1, and I want to merge it with plot 2. So actually that is the true picture where you can easily see the area, shaded area between these two curves from -1 to +1. Okay, students, there is another command uh, related to the area. If you want to compute the area between two curves and want to get the answer within some seconds or within some minutes, so just write down that command of integrate in Mathematica and write down the function's name. Our first function name was f of x minus second function name was g of x. We want to integrate f of x minus g of x, and we want to integrate it from the limits of x from -1 to +1. So as I give the command or as I execute it, so my answer is 104/15 square units. So that is actually matched with that answer. Okay, the second question is question number 82. Here also we have the two curves given here. So here we can easily write down the variable y in terms of x. Like from the first curve, we have y equal to x cube. From the second curve, we have y equal to 3x square minus 4. So that informs me that I am interested to get the projection along x-axis. So what will be the difference? F of x minus g of x will be x cube minus 3x square plus 4. For limits, you need to equate them to 0. So as I equate it to 0, I will get the two values -1 and +2. So area formula is just integral f of x minus g of x from x equal to a to x equal to b. So put the expression of f minus g here, integrate it, and apply the limits. So as I apply the limits, my answer or the required area is 27/4. So here below, that is the graphical touch related to these two curves, and that shaded region indicate the area enclosed between these two curves. So let's try to solve it with the help of Mathematica. So if I wish to solve it with the help of Mathematica, so first I need to rewrite my function. So here my first function is, okay, my first function is, students please wait. Okay, my first function is x cube. So here I am writing down x cube, and the second function is 3 multiplied by x square minus 4. So first let me allow to quit the kernel. So this is the command I am executing. Actually, I am running these functions, executing these functions. So after that, this is the plot of the first function, area between x-axis and that curve. Now plot g of x. Okay. Now plot these two functions combined. Okay, students, but actually we need to find out the area that is enclosed or bounded by these two curves. Actually, that starts from -1 and ends at 2. So let's plot these functions, and then by filling command. Okay, in the filling command, I need to revise the limits. Actually, my limits are from -1 to 2, and then needed to merge these two plots. So that is the graph. That is the actual graph, and that is the actual area, shaded area that we needed to require in units. So you can match it with my rough graph here. And as I integrate it from -1 to 2, can my area be equal to 27/4? Yes, Mathematica also informs me that my answer is 27/4. Okay, students, I am going ahead. So after that, question number 83. Here I am choosing the projection along x-axis. For that, I am expressing x in terms of y. And from the second equation, also express x in terms of y. Name the first equation p of y and name the second equation q of y. For limits, equate them. And at the end, my root will be, there are 4 roots, y equal to +(-1), y equal to +(-3). And to get the point of the intersection where these two curves intersect, I put y equal to +(-1) in the first equation. In this equation, as I put y equal to +(-1) here, my x will be 0. And my second y values are y equal to +(-1)√3. Again, put it here, but noted that my x should be greater than or equal to 0. But as I put the value of y in the first curve, my x will be negative. So that contradict my given condition that x is greater than or equal to 0. So I need to ignore that point. So this informed me that my y limits are from -1 to +1. So the total area in this case will be integral -1 to +1 p of y minus q of y with respect to y within absolute sign. Okay, integrate the curve. Hopefully you will do the integration. So at the end, answer is 56/15. So you people also confirm it with the help of Mathematica as well as manually check it. Now the next question is question number 85 to 92. Find the area of the region enclosed by the lines and the curves in the exercise 85 to 92. So here are two curves and the limits of x are given from 0 to pi. So simply students, no need to go for computing the values of x, no need to do that. Only you need to subtract or find the difference between these two functions, either find out f minus g or g minus f. So I am using or I am computing 2 sine x minus sine 2x. So limits of x are already given here. So integrate it from 0 to pi. So integrate carefully, and as I solve it, the area under the curve is 4. So please come to question number 87. Here the two curves are given, but the values of x are not given. So I just randomly put x equal to 0 in the first function. The first function gives me 1. In the second function also gives me 1. So that indicates that at x equal to 0, these two curves intersect. So now I am putting x equal to 1 in the first curve as well as in the second curve. Both of the function gives me the value of 0. So that indicates that x equal to 1 is one of the root of these two curves or these two functions. So as I put x equal to -1, f of -1 is 0, g of -1 is also 0. That indicates that -1 is also the root of these two curves. So here I have sketched these these two curves. So that is the curve that representing y equal to cos, just wait. So that curve indicate y equal to cos pi x over 2, and that curve represent y equal to 1 minus x square. So from the second curve, I compute x square equal to 1 minus y, and I think no need to do that. Actually, I need to find out the area, and I am using the projection along x-axis. So along x-axis, the area that is bounded between these two curves start from -1 and ends at +1. So simply you need to integrate f minus g. What is f here? Cos pi x over 2. What is g here? 1 minus x square, and integrate it from -1 to 1. So after careful integration, you do the calculations. My answer is 4 over pi minus 4 over 3. But as I computed it, that indicate that my answer is negative, but noted that area is always positive. So I ignore their negative sign and just revert the sign, and my actual answer will be 4 over 3 minus 4 over pi. So similarly, students, you solve question number 89. So that is the rough area between the two curves secant square x and tangent square x. So hopefully I will also share the PDF slides with you so you people can easily understand it. So question number 93 is also here. So students, you please read it carefully. But the important thing is that here I am using the projection along y-axis. So I am skipping it at that time, but PDF files will be shared with you. So you people please understand it. So please come to question number 103. Okay, please come to, this is question number 103. The region bounded below by the parabola y equal to x square and above by the line y equal to 4 is to be partitioned into two subsections of equal areas by cutting across it with the horizontal line y equal to c. So that is the main theme. So he says that the area that is bounded by y equal to x square and the horizontal line y equal to 4 actually partition into two subsections of equal area, but that is obtained by cutting through the horizontal line y equal to c. That means y equal to c, you need to draw the line y equal to c in such a way on the region bounded by y equal to x square and y equal to 4. In such a way, you need to draw the line y equal to c that it divides the above area into two equal sub areas. So first part is sketch the region and draw the line y equal to c. And in terms of C, what are the coordinates of the points where the line and the parabola intersect? Add them to your figure. So let's go to the solution. So here I have the solution. Sorry. So this is the solution. So actually the given curves is y equal to x square, y equal to 4. So first I wish to find out the area between these two curves. So I am choosing the projection along x-axis. So clearly the limits are from -2 to +2. How? Y equal to 4. Put y equal to 4 here. As you put y equal to 4 here, x square equal to 4, and the values of x will be -2 and +2. So subtract these two curves. Subtract 4 from x square and integrate it from -2 to 2. Integrate it. So our area is 32 by 3, but we are interested in the half area. So half of the area of 32 by 3 will be 16 by 3. So why we interested in the half area? Because we need to draw a line y equal to c on that bounded area in such a way that y equal to c divide the whole area into the half area. So that's why I assume that, or I roughly suppose that that from that value of y-axis, I draw a line y equal to c. I draw a horizontal line that passes through y equal to c. First, I am interested to get the values of c. Sorry, first I want to find out the point of intersection where the line y equal to c and y equal to x square meet. So for that, equate these two curves. I will get x square equal to c, x equal to positive negative under root c. So my x is positive under root c and negative under root c, but my y is c here. So you can also watch it from the graph. So this point indicates the first point minus under root c comma c, and that elaborates the second point. Now b part. So come to the b part. If I go back, so in b part, find c by integrating with respect to y. So integration with respect to y means we need to choose the projection along y-axis. So again, I'm moving towards the solution. So here, again, I choose the same graph, but noted that in the B part, I need to choose the projection along y-axis. For projection along y-axis, you need to convert the curve y equal to x square in terms of x equal to under root y and x equal to negative under root y. So actually that curve represent x equal to positive under root y, and here that curve represent x equal to negative under root y. So the half area in this case will be just integrate under root y minus under root y and use the limits of y. The limits of y are actually from 0 to c. We get 2 under root y, and as I done the integration, apply the limits here. As I apply the limits, I will get the answer. Actually, that is the half area. But that half area is actually equal to 16 by 3. So from here, I be able to get the value of c. So my value of c is 4 raised to power 2 by 3. So in the c part, he again says that repeat the question, find out c, but now you need to do the integration with respect to x-axis. Integration with respect to x-axis means choose the projection along x-axis. So once again, I choose the same curve y equal to x square and y equal to c. And I wish to find out the area between these two curves. So that's why I need to integrate x square minus c along with the limits of x. So the limits of x are from negative under root c to positive under root c. So integrate it, finish the integration, apply the limits, and my answer will be 4 times c raised to power 3 by 2 divided by 3. But that is actually the half area, which is equal to 16 by 3. And as I solve it, my answer of c will be c equal to 4 raised to power 2 by 3. So students, you need to finish the complete exercise. And if you face some queries, please share the queries in the live class. Okay, thank you very much, and take care, students.